Hello and welcome back. Hey, Dan, thanks for joining today.
Hey, thanks for having me.
It is our third hardware live stream, and people may have noticed there is a little more hardware on the screen now, which is great. I was just showing Dan a little mind trick that I've been dealing with here. So I asked Dan. So Dan, maybe we can just repeat our little performance there.
Sure.
How large do you think that this module is that we've been talking about designing?
I think it is slightly larger than a credit card.
Right, and then I held this up to the camera. I cut it out of paper. I measured it and cut it out of paper. And if we just scale it back here, it's about that big. Or I actually happen to have a credit card out at the time. So this is how big the module is that we're designing. It's just like,
Very
oh
small.
man, yeah, we're really squeezing things down here. Not the smallest thing in the world, but not big either. You may also notice there are 4 of them now. So I guess I should probably talk about that a little bit too. There's also a Goliath, the Goliath logo. That's the Goliath is the name of our company logo here. I made one in the shape of this as well for funsies, but also just to see if I could make a module fit on there. And I sized it a little poorly. I need to scale it by another millimeter, I think. Basically, so this is 34. I don't know if you see my mouse. You do. So the long side of the Dram module is 34 millimeters long. The short side is 24 millimeters long. And it was a guess based on the original, things we talked about with the click headers, the microbus click header. And just trying to size it around that, just seeing what the smallest one is. I need to make another board here to fit the micro Dram like we talked about. But that's kind of how we got it all sized. And then I made the length of the Goliath torso be 34 millimeters exactly. But the problem is then we're going to make castellated edges today. So that's what we're going to be doing today. I guess it took me 2 minutes to say that. And then you need to make landing pads for it so that you can solder down that module. And then you need a little bit extra room there. So at least another millimeter or 2. So I'll probably just upsize the Goliath logo a little bit. His torso is actually square. So there's some stuff on the side there. And then we'll have a slightly larger Goliath. But even still, this is only like 80 some millimeters across. So I guess I can go, where can I go? Here. There we go. So if I mouse over, hit the space bar, go across, this is hide. This is that 34 millimeters I talked about, but even arm to arm. So now again, space bar, I think it's 80 millimeters, which is about 2.5 inches. No, that's wrong. 3.25 inches. So 25.4 millimeters to a inch. So a little bit more than 3 inches. So like not big. And even still, this is just kind of a goofy little promotional thing that I did. And just to show that the Dram module is going to go onto a couple different things. And so we're just trying to size it up here as well. Let me pull the pin planning sheet. So we started talking about this. I've been doing quite a bit of kind of work outside of this as well. And it's all to see that we can get everything working here, right? So this is readable, Dan?
Yep, that looks great.
Okay. And so at the end of the day, what I want to do is I want to make sure that if we have multiple chipsets on this module, that they all kind of work. And so this actually came also from the Sloshy McWashy Friday live stream that we do. And we started talking about can we fit the same functionality of the Elixir onto the C3? So the ESP32C3 has fewer pins overall, but with the GPIO expander, we could potentially do that. And so then so if we look at this one here, it was kind of a thought exercise of like, okay, so we're going to have an ESP32C3, which is a lower cost version, lower requirements overall. The Sloshy McWashy only needs 1 pin, but again, when we're designing a module, you have to design the least common denominator in this case. So if the ESP32C3 only has so many GPIOs, and you're going to add an expander, you need to make sure you can cover all your bases there. And so because I designed the module to be a replacement for the Elixir, right? So the Elixir is the board that we just open sourced. So if you look at the blog.collab.io and you look, oh my gosh, look at all those pipelines. Nice job, Dan. This guy's keeping busy. So the Elixir is this one here. And so basically we're kind of shrinkifying a lot of the stuff that's on the back of here currently. Not the power stuff, but really like the 9160 module, ESP32C3 module, right? And kind of the core functionality, we're going to shrink all that down. And it'll probably fit into the same kind of area here. But I want all the functionality to stay the same, right? So we can get out to these dual microbus headers, that we can have quick headers, just using this as a constraint because we are unconstrained at the start. That's where this all came from. And can we do this, right? So that's where kind of this pin planning came from now. So now we said, okay, we have the C3. For Slossie McWashy, we only need what, like, how many pins do we even need for that, Dan? It was like 2-3 pins total, maybe? Yeah, it was like an I2C. Yeah. Very simple feature set, but it still has to carry along all the costs of doing this other stuff as well, right? So when you design something module like this, you still have to carry all those costs with you. Hopefully in this case, it's a PCB, so that you can no pop things like the Sloshy McWashy as well is not going to need the BG77 at first to do cellular, because we're not going to do cellular at first with Sloshy McWashy. We still need to carry that with you. So now it's like, okay, we're just going to have the footprint there, not populate it, still use the same module outline so that later, if you want to swap it in, you can, or you could change, or in this case, if you want a different Dram module entirely, say you want to have NRF52 840 plus the BG77 or the NRF51 with the ESP32C3, Wi-Fi offloading. Your abstraction around the edge of this module lets you do that, but you need to plan for that up front. So whereas premature optimization is, what do they say with premature optimization? It's like the enemy of projects or something like that.
Root of all evil.
Not in hardware. Because you have to think about this. Again, if you're abstracting at the level we're talking about here, we're going to get something wrong. There's no doubt about that. Like, I'm just completely sure about that. In fact, there is something that's already broken here, and I will call that out here. So if we wanted to use the ESP32C3, I could not figure out any other way to do it. So basically what I did is I said every expander pin, anything that's a simple GPIO, so like you're just turning on the 5-volt enable pin to the external power supply on the Elixir board, right? That's just a simple on-off, super easy sort of thing. That can go into GPIO expander. You just talk to GPIO expander, it flips a bit, no problem. You can't do things like, you can't do an analog measurement or analog output without a lot of other fanciness in there. And so I kind of label these all as simple GPIOs, right? Anything that was not a simple GPIO needs to have an actual pin assigned. And then you have, the fabric internal to a lot of these chipsets that allows you to switch things in. Same thing with like flash. You want to make sure your flash is available, that sort of thing. So it's really just a lot of like jockeying for position. Like I said, I'm sure certain things are broken and wrong here. But probably the most glaring example of this, as far as I can tell so far, is the buzzer. So the buzzer on the Elixir might not work great with the ESP32C3, but that's kind of that's only one of these 3 modules, and we might be able to find a workaround. Sometimes you can do PWM kind of weirdness. Like we could have a process that just turns it on or off because the buzzer really only uses 50% duty cycle anyways at different frequencies. So we might be okay there anyways, but this is the one where I kind of ran out of pins. So that's if you want to use the C3, this is the kind of trade-off you have to make here.
And the what makes a pin a candidate for being on the expander versus not?
So it's that simple like GPIO on off kind of capability. So anything with like this, you see I have like PWM complex, right? You can't, unless you're going to use a very special GPIO expander, you can't really count on having PWM available there. So like that probably has to be on just a generic pin. You see there's just generic pins here now.
Right.
Things
and
like
at like a fundamental level, it's like things that depend on any sort of precise timing, right?
Precise timing or specialized silicon as well, right? So again, like another good example here is like I2C, right? That could not go on a GPIO expander because one, that's a bus. It's got a pull up, pull down kind of, or really it's open drain. And so just doesn't work. You can't guarantee that the expander would have an open drain available. And then it also would need access to the specific silicon. So like I2C controllers inside of NRF 52840 or the ESP32C3, they actually have like registers that then talk out to specialized silicon. So you write into the register, you write a byte in, and then it says, "Oh, I know what to do with this. Don't worry about me." And then it shifts it out on the bus, that sort of thing. So,
right. And I feel like the like critical point in all of that is that like the GPIO expander is not just like you can't just like pass. It's not just like a wire, right?
Yeah. Right.
So yeah, that's kind of what.
Yeah, it's like like the way to think about it is basically a shift register. Even though it's much more complex than a shift register, that's the easiest way to think about it. You could also, some of these you could replace with a shift register as well, but you need, at an OS level then. So if you use one of the Zephyr expanders, you can actually use the drivers that are in there and it kind of just disappears, right? It just, basically the OS has a driver that talks I2C out of this device. It maps the GPIOs. It understands where the things are. And then it kind of looks the same, right? But you don't get all the same functionality as like an I2C or something like that. So, okay. Lots of this kind of weirdness here. Like I said, I think some of the stuff's wrong. You'll also notice that I started adding the S3 here. I didn't finish this, but I started, at least I wanted to make sure it had kind of all the key things in there. And I am going to make a fourth module, right? So, or I'm going to kind of outline a fourth module here, because I think in the short term, I might even push on the schematic team to not use the expander. Maybe not. I don't know. But in terms of like, when I talk to Dan and Dylan and John and Mike, who else is doing Sloshy? Oh, and Sam. All I'm going to give them is the footprint for the Dram module, and it should be enough, right? It's basically like you put a USB to serial converter on your Sloshy McWashy board. You put the Dram footprint, you put the sensor you want to put on there, and that should be enough. That's kind of the goal here. And then my job is to continue to make different Dram modules that have different functions and features and capabilities. You do a different, board outline layer in Zephyr, and then your, kind of looks the same now, or ESP IDF, right? Looks the same. That is a lot of hand waving with that statement, but that is, in theory, that's the idea there. Okay, so other things that are going to come up in today's thing, because what we're going to do is hopefully just jump right into this, is I added pin names, right? So now, because we're creating, again, an abstraction layer of sorts, connectors are abstraction layers, module card edges are abstraction layers, that sort of thing. We need to actually give them names. And in doing so, I need to be able to also kind of alert the user that there are certain things in there that they do or don't want to do. And so that's what I did here. So let's start with the simple case. I'm not sure about this name specifically. It's probably not a great naming scheme, but that's Dram GPIO 19, right? So that one right there. That's just a complex GPIO. It has access to all the I2C, whatever. You could reassign it if you want to. I expect you to probably follow this same, if you want a serial output, I expect you to use, 19 and 20 for that. But you don't have to, right? That's kind of always the thing there. And you could always remap it later. But you need to indicate that on the edge of the module. Like I said, the Elixir functions are basically the closest approximations of what most applications need, not all, of course. And so I expect you to kind of follow that. I would not suggest that you switch TX and RX just to some random other pin, because it's not worth it. Especially at the form factor we're talking about here. Like, you're at the board level, you could probably route the TX and RX to these pins. But they should have access. So you see these are kind of all generic GPIOs that should have access to all the functionalities of the underlying pins, the 9151, 52840, the ESP32C3, and the S3. Some of the other ones, though, if it's on the expander, I want to indicate that, and that's where the S comes in. So DG09S. So that says, hey, if you're just looking at that, you see an S, hopefully why is that different? Oh, it's different because it needs to be simple. Hopefully just triggers enough of a, just enough of a trigger to be like, why does this say S? I know that that's a very, very lightweight control mechanism there. Same thing here. There's 2 pins. These are the 2 analog pins on the click. These are really ADCs. There's no DAC output there. There are DACs on some of these. And then I also created some optional pins, which again, I kind of think of these like on a lot of cellular modules. They'll have like reserve pins for future silicon that they hope to put there. Whether or not this is a great idea, I'm not sure. But this is where we're starting from. And hopefully we're actually starting some stuff here. Okay, so what's next, Dan? I think we go and build stuff now.
Sounds good to me.
Okay. Anything I'm missing? I actually have to change these names here too. Anything I'm missing here?
I don't think so.
Okay. I missed the Sloshy McWashy live stream on Friday. Was there any updates there?
It was just Sam and I, and or Sam and me, I guess I should say. Sam and I just worked on getting the firmware set up. So we got like the Zephyr application set up, and I have somewhere around here a little C3 dev board that we were just messing around with. So yeah, we were just talking about that. Talked a little bit about like Sam's process for planning and building firmware and that sort of thing. But yeah, nothing really on the hardware front.
Okay. All right, great. Well, let's start with this then. I'm going to first create a Dram symbol, right? So we're going to go back to KiCad. I'm going to create a Dram symbol, and we're going to create a Dram footprint. And hopefully in 45 minutes, we could finish that. And then we could drop that onto these boards here. One thing to note here is because we know the shape, I've also been doing other stuff on here. So I've been just kind of like checking myself around like, all right, we're going to have flash. Is flash going to fit? This is the MFF2 eSIM. Is that going to fit, right? I'm actually a little worried about this, the courtyard that they say for the BG77. I am almost certain that comes from the data sheet. So just want to make sure, like, is that going to, do we really need to have that much spacing here? Because it's significant. I also placed UFL connect. These are the UFL connectors. So these are, if you want to have, you need to have the RF energy go somewhere. And so we're kind of having GNSS on the left, LTM on the right. And actually that naming scheme is probably a little bit reductive as well, because I would actually love to have a Cat1 or Cat1 bis version of this at some point as well, because that also opens up other capabilities, but they're listed as M because it is both the BG77 and the 9151 are Cat M1 and NB-IoT only. This is going to be the 2.4 gigahertz in the lower left here. And again, I know this is overdoing it on all this stuff, but it's because I'm trying to kind of pin plan and figure out where do I want to have stuff. Do I want to have these in all 4 corners? I think so. I think that's the best placement for this stuff, but you want to just know it up front, because you have to, once you decide, then it's really, you don't have a lot of options after that. What that also means to me is that we probably want to have just the pins on the edges here. And if we're going to do a standard 0.1 inch spacing, we're only going to have so much kind of real estate. So that's going to be another limiting factor here. All right. Yeah, actually, now that I think about the size of this thing, we might have to downsize even, because this is 34 millimeters, 24 millimeters. This is like about an inch wide and about inch and 1.3 inches long. So that means we get about 10, 10, and 13 on each side. So that'd be 43 pins, which is probably a low number generally. So need to think about that. All right. So what did I say we're going to do first? Save this. Let's go here. Another thing I did is I wanted to make it very obvious when you go into different schematic sheets which one you're looking at. So, oops. Let's move all these back down onto the sheet. So this is the board where we're going to land the module, and these are the 4 modules that we're building. All right. So first things first, though, let's go build a schematic symbol. Have you ever built a schematic symbol before, Dan?
I have not.
Okay. This is going to be exciting. Oh, boy. All right. I haven't done this in a while, to be honest. So you can see that we have some of our own libraries in here. So like this is some of the stuff where I went to SnapEDA or other footprint kind of sources, and they got added. So like this just has the BG77 in it, right? That's this one here. You can see that. I don't want to add it to that. So really what I really want to do is create a new library first. And I want it to be project specific. Input symbols. I'm just going to call this the Dram library. All right, so now that's been added here. And I can right click, say new symbol. We'll call this Dram outline. Dram edge. Give it the default designator, units per package, just one. It'll be like a big symbol like this one is. Okay. All right, so that's just creating an outline there. Let's give it some background. All right, so now I really just want to go and fill in for the Dram pin names that I have here. And at one point, I thought there was a way to import. I don't know if there still is. In table.
And so you're creating this symbol to essentially like make it so that us or another person in the future can integrate with one of these modules, right? So this is kind of like the interface for a landing board or whatever.
So the symbol, yeah, that's a good question. So this is, Mike's in the chat. The symbol is actually going to be the same for both the module itself. So we're actually making the symbol for the module right now, but the same symbol is actually going to be used for the landing board. So just as just to go back to the 3D model again. Mm-hmm. So we're creating a symbol right now that's going onto these little guys, but the same symbol will be used on the Goliath, which is going to have one of the Dram modules put onto it, right? Because we want to basically have like a indicator of what gets hooked up to what.
Right, right. So in that case, it makes. Oh, I see. Because like so I was thinking just in like the Goliath case here, where it's like, let's say, I mean, it's the same as like the symbol that we'll have for like the C3 or something like that, right? That you want to add onto your board. What I wasn't thinking of is like we both need to be able to wire the Goliath up to it, and also on the other side of that equation, wire the modules up to the interface there.
Yeah,
right?
That's right. Yep.
It's like the output pins basically for the module.
Yeah, right.
Or output. I probably shouldn't use the word output there, but it's the interface between these two. If both are wired to it correctly, then they'll work together.
Okay, so I hadn't used this in a while. So this is the pin table. So it's just going to create a range of pins for me here, which is actually, that is what I want. So I'm going to just go and do that here. I don't think there's a way to, oops. Pin table. I was hoping there was a way to just copy paste in here. I'm not certain there is. Let's try it though, right? So I'm gonna number name. Yeah, so I'm gonna assign. So it wants a number because eventually we're gonna create a footprint that actually has a number attached to it. So like pad 1 might be ground, pad 2 might be DGOOS, right? And it wants to basically make that as an index for them. So we're gonna let's do 4. Oh, can I not do that? Okay, I thought I could. Pin numbers. Let's see what happens. So it does let me enter and add new ones there. Let's see what happens when I do this. No, it doesn't like that. Let's try this. I'd love to not have typos. All right, look at that. Except I already put a typo in here. This is like really showing where a lot of the errors can happen in your schematic. Schematic errors are the worst type of errors because it's like everything looks like it's hooked up properly. But then you're like, why doesn't this work? It's like, oh, because I labeled it wrong 4 months ago. Two, 3, 4, 5, 6, 7. 14. Great. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Pretty much nothing gets more exciting than watching someone make a symbol. That's interesting. It makes space. It converts spaces into underscores there. Two, 3, 4, 6. Okay. 2, 3, 4. Okay. All right, there we go. So this is where we're currently at with this. We have all these names here. One thing I will probably do off camera is I'd actually like to have the Elixir function labeled in there as well, like in a parentheses. Because again, when we start to have things like, so like where should I hook? So say we're doing sloshy McWashy, we want to know where should we hook it up to. It'd be nice to see like in the schematic symbol, oh, DG2122, those are usually SDA and SCL, right? And basically just put those in parentheses so that we know when we're looking at the symbol, again, either on the module side or on the thing we're landing the module onto, SDA and SCL are normally on DG21 and 22. Doesn't have to be those, but it's kind of a best practice. You just kind of label it right in there. All right, this thing is going to stay ugly, I think. We don't currently have numbers assigned to here. One thing that's we could do, we can kind of go back and forth with the schematic and the footprint as well. You see, these are all listed as unspecified. What that just means is there's error checking. So you can go into individual pin here and say, oh, this one's going to be a power pin, right? Or a open collector, open emitter, that sort of thing, right? We're not going to do any of that stuff because then it's just going to, unspecified means it just skips that part of the checking. And it'll be on us to make that work. I don't know why it had multiples. In the pin table, it had count. Oh, maybe it starts to just group by name. There we go. Group selected. I see. So if we did another ground pin here, where'd it go? It is not letting me discard changes. I think if I go and add another ground pin here, and I name it 2, I think it'll group by name. Yeah, there we go. So now it does 1, 2, and it counts the number of pins here, right? And that's nice if you do have a bunch of ground pins. So I think we could even do this. Let's see if this works. Yeah, so now it layered a bunch of ground pins on top. And that's the kind of thing where we do probably want to have multiple ground pins here. Especially things like I was thinking about it at the top of the module where we have the RF hooked up. You want to have a nice solid ground connection between the module itself and the underlying board it's connected to. We've not yet assigned pin numbers to these other things here, but we will do that shortly. Okay. All right, so that should be sufficient for now. Let's go and drop this into the actual Dram, one of the Dram modules. We're just going to work on Dram 1 right now, and then we'll kind of copy paste it into other ones later. So if I select, let's just select a part here. Because it links the schematic and the layout together, it took me to the Dram 1 page. And so now I'm going to go and hit A. I should be able to filter on Dram. Dram edge. And now there's no footprint associated with this. And that's what we ultimately want to get to. And this is going to be kind of a back and forth here as we get this figured out. But let's go and create a footprint. Oops. So that we can start to see it show up on the layout here. So if I go to the layout and I click this button here, just create a new footprint editor. I have to create a new, actually, we already have a library. So there's the Dram library. This contains all of this is the dram.pretty that we created in the past. I'm going to right click, say new footprint. We'll call it Dram outline or Dram edge rather. That's what we call the other one. We're going to say this is an, let's do it other type footprint. All right, I'm going to draw a reference outline here on the, let's do user drawings. And then I'm going to match the outline that we have. So I'm going to go to, let's change the grid. Let's go to millimeters. So let's go to 1 millimeter grid. And then I'm going to go here. You see I'm at 0, 0. I'm going to go to -12 plus 17. Sorry, -12 minus 17 in the upper left quadrant. And that's going to make us it should make, am I in the wrong direction? No, I'm in the right direction. This should make us a 24 by 34 board. So now that's plus 12 in X, minus 17 in the Y. That's just should take us 34 down, 24 across, 24 up. There we go. And so now this is just a representation of the actual outline we're going to use on the board itself. And now we can start placing footprints. And let's do that here, or pads rather. So I'm going to do this. Let's just do across the top here. Now with a castellated edge, we're going to do a castellated edge where we basically just make a through hole. And you basically say, oh, the card edge cuts right, sorry, the board edge cuts right through the castellated edge. And so they're going to actually make this board, they're going to put the through hole in there. They're going to route around it so that it cuts them in half effectively. And then they'll back plate so that the entire, so that they plate the rest of the edge there. We'll have to mark it specifically in at the board manufacturer. All right, so let's do this. What is my grid here? My grid's on 1 millimeter. So now we're going to actually switch our grid to be inches, which is fun. So we're going to do a 0.1 inch grid here. Oh boy. This is where it gets a little tricky. What do I want to do here, Dan? I want to do
What are you running into?
Just grid problems. If you're having grid problems, I feel bad for you, son. I got 99 mils, but I forgot the 0.1. Sorry. So basically, my board edge
there
is on the board edge is on millimeters,
and
then this is on. I'm trying to do 0.1 inch. Oh, that's way too big. Maybe I don't need to do this as. I'm going to do the same size, I think. All right, let's go back to the other grid. So I was at 1 millimeter grid. So I could, just as an example here, I could do this sort of thing. So maybe do every 2 millimeters. So like a 2 millimeter grid. So just as an example, it would look something like this, right? And then if we pull, okay, so now I have this module, or actually I have this footprint. Remember, this is on the user drawing layer, and so all that's really going to come through is these pins, I think. So let's go assign that in the schematic layer. Window. All right, so the footprint we're going to assign. It's Dram edge. Hit OK. Go to the layout. Where is my layout? And then I hit F8. That should hopefully update this in here. That did not work. That's my grid. When I placed the original, it was not at the same grid size, so. I might just have to go and redraw the board outline to match this. It's a little bit off. Yeah.
Do their sizes not align, or is it just you can't get it lined up correctly here?
It's just when I drew, I'm not sure. I must have moved. So one of the problems is like aligning the grids is kind of a problem, right? Because it's all arbitrary. And so when I set the grid, I could have been drawing it, even though I was drawing it 34 by 24 millimeters. I could have been drawing it on, like it could have been on the mils grid instead of the millimeters grid, right? So in imperial instead of metric. And so I might just want there's actually a feature in KiCad 8 where they allow you to align to the grid in the schematic tool. I'm not sure about here. Ultimately, I don't think I should just let's just make 1 millimeter grid here. Let's place. We're so early in the process. It's probably better to just move this thing to be on that grid. Let's just move this down here. And then we can go and map a new outline layer directly on top of it. Or sorry, an edge cuts layer. So this should be, so you see how that's like right dead smack on the corner here?
Right.
Ultimately, that's what I want to be doing here. So I'll just align that and make that work better. And you even see it's like lining up the corners. And then if you've never seen it here before as well, the selection filter is kind of a newish thing. I think in KiCad 7 that came up, but I really like it for this sort of thing. So you can actually say, I don't want to choose any of the graphics. And so I can go and select everything here and move that. But you see it did not grab the board outline because that's a graphic layer. And now everything's aligned to this. I mean, mostly aligned. I usually try and stay, this is different for different people, but usually I do 0.1 millimeters as my smallest layout grid, unless I'm really, really tight. So, all right, so there we go. And, this is all very, very rough still, right? That's another thing to note. Just getting it roughed in here. So I'll delete this one here. Oh, no, I didn't select it. I have to go back to turn on the selection item. I didn't want to select the text. All right, and now we're kind of back to square one. It's extra tricky when you switch to between imperial and metric. Okay, so what I expect to see now, because we have a through hole here, we have an edge cut through there. I'm expecting and hoping when we look at the 3D model, it actually shows it as a castellated edge. Let's see if that came to fruition. It might actually show the entire through hole. Actually, I think it will. All three. Oh, nope. It shows the castellated edge. Look at that.
Nice.
Beautiful. Beautiful. So that's great. And that's kind of what I expect the board house to do as well. That's that same kind of level. And now we're going to continue on with assigning pin locations now. So I'm going to go and add new pins to be doing that same thing here. Actually, now that I think about it, I'd like to do, so these are all grounds. So if you look at the GNSS and LTM and the 2.4 gigahertz things here, those larger pads are UFL, like ground pads, and then the signal comes into the smaller pad here. And I think having kind of ground pads all the way around those is probably a good idea. Maybe even to the point where we have them on the corners, and then we bump in. I'm not sure about giving up some of, we're going to have a ground layer on this module as well. It'll be a 4-layer board for the module, but so maybe we just go up to the edge here. But we need a lot more ground pads as a result. So probably let's see what happens when we do that too. Yeah, that'll be fine. It's because we're going to be routing out from these to things like this. So like if we were going to a ground pad, well, none of these are actually assigned right now. What am I selecting right now? It's fine. Okay. Yeah, see, none of these pins are actually been assigned to the ground pads on the Dram card edge footprint. All right, let's just add a bunch more here. Let's move. So we're back in the schematic symbol editor right now. No, I'm not. That's the should move this up. That's the actual symbol in the schematic right now. So we need to go to the symbol editor, which is, I guess I can get to it from here. If you right click or mouse over, hit E, and then hit edit library symbol, that should take us to the symbol editor. Okay, so now we're back in the symbol editor. Okay, let's make another. We got 5 there, probably another 4 at the top, 2 on the sides. It's another 4, 8, 4. It's another 16. Let's do 20 total. We should be able to do this by pin table. Group by name. Okay, now we got 21 grounds. Save that. We're going to go back here. The module here. Go to the layout or the footprint editor. Let's make these make a little more sense. Okay, there's 8. Don't worry, Sila. You're doing fine. If you're using Altium at the same time, that's impressive in its own right. I can't do layout. I can barely do layout while I'm talking to Dan, let alone watching a stream. Move these down 1. Let's see how that looks just to the naked eye. Layout. So I think we might have to update the footprint. So now, okay, so now we have the footprint that's already been in here. Now you have to go and to say update footprint from library, I think. And now we see we have additional modules here. That's not bad. That was a pretty good guess. Okay, so now we have that. And so as I'm just going to kind of do side by side, just go back and forth, see how it looks. I'm going to keep adding other ones here. Let's see what this is. So there's just a difference of, that's 6 millimeters. So I'm going to go from here to here. That's also 6 millimeters. I'm just kind of eyeballing this at first. From here, that's 6 millimeters. Doing pretty okay there. Here to here. Oops, that should be reversed. Dan, is this all making sense to you, what I'm doing?
The parts that I'm watching, yes.
Okay. So I think that should look okay. That's what that looks like. Let's hit save on that. Let's go back here. Got a lot of windows going on here. Let's turn off. How do I turn off this table? Select the footprint here. Update from library. All right. That feels pretty good. So now we have basically grounds all around these things. We'll also have ground pores probably underneath the, so we'll have a ground layer throughout the whole thing. We'll have ground pore kind of in this corners. See how this looks. So there's what the module edge looks like. So now what do we have to work with here? We basically have like this down here and these here. So let's go check on the number of pins we have remaining to make sure I'm not making this really tough on myself. I probably am. All right, so we have, I guess I have a spreadsheet. I can just use the spreadsheet. So there's 47 pins if you take out the, all right, does that include these? Oh, it does. Okay, so we have, oh, there we go. I already did this once. Number of edge pins for the Dram module, 36. So 35 additional pins we need to fit in here if we use all those. That might be kind of a stretch. So I guess we could lose one of the 2 pins on the corners here. But let's just try and go to do that first. Okay, so we're at, so we got to 20. So now we would have to get to 55. I guess we can math this if we need to. So we have 18. So I mean we can get 7 between there. Let's see. 1, 2, 3, 5, 6, 7, 8 between there. Okay. Okay, so 8 on this side, 8 on this side. Not even close. Oh, Dan, we're running out of room here. Okay. So that makes me think we need to rethink how I did this.
You probably mentioned this while I was working on other things, but why did you start by placing the ground pins?
Because really, I'm trying to make it so that the we know the UFLs have to be there, and so this is all kind of space constrained. So like, what does that end up looking like? So like, if we know we have to have the UFLs there, we want a good ground connection. I'm wondering if maybe I could make, oh, and then I don't want to have to bump them in too much, right? So maybe if I did something like this. So now maybe we do this. So maybe we just do the corners like this, and we give up a little bit of real estate, but we still keep the good ground connection. Because I think I give up a little bit of real estate on the inside of the board, but the outside of the board stays. We need more edges for modules. The other thing we could do is we could make the actual castellations smaller, but then that makes it worse for soldering and other stuff later.
Right.
Did you ever watch Whose Line Is It Anyways back in the day?
I didn't know.
They had
I'm
this, like,
familiar with it though.
Okay. Drew Carey had this thing where he says the points are made up and the rules don't matter, or something like that. Kind of like that here too, right? I'm just kind of trying to make sure all the stuff fits and making something that makes sense here. One of the mistakes I made, I've done a module in the past when I was at Hologram, and one of the mistakes I made was thinking that I was going to make it so that it could be pluggable into a 0.1-inch header board, which is stupid. That was a stupid idea on my part, because it was like nobody was ever going to do that anyways, except for maybe me. And it's like, it's a dumb thing to optimize for. So like I did 0.1-inch spacing, which is fine. But then I ended up having it where like there was stuff, if you don't just do the sides, you only have like the vertical pins. You can't use the bottom of the top edge then. So it's like, oh, well, that kind of defeats the purpose of a lot of this stuff.
Right.
And it wasn't really a use case, so.
Gotcha.
All right, so let's update the module for the library. All right, what does this look like now? So now I'd have to go basically here. Grid. I mean, from a placement perspective too, we probably don't want to have these things right on the board edge anyways. So like, it's not the worst idea, but then everything kind of gets squeezed in as you're seeing here. What I'm really trying to figure out in the short term though, is like, did I guess wrong on 24 by 34, right? Because that ends up just rippling back through the design quite significantly. And what you really don't want to do is you don't want to have that happen like 6 months from now. Not saying this is going to have the most longevity, but these are the kind of things I think about. Is that if you're going to have these things happen, you want them to happen you want to make these mistakes as soon as possible.
Mm-hmm.
Let's take a look what this looks like. So there's the ground pins there. There's the module there. So Dan, what do you think?
Perfect. Ship it.
Yeah, ship it. I think the other thing I'm concerned about generally is like the 9151 is fine. Honestly, it's going to be no problem at all. The downside is when we start doing things like going to other modules, right? So the BG77 is not that much bigger, but you can see how much like another 5 millimeters on the module really starts to impact things.
Right.
And we have to still have controlled impedance lines running from the module out to the UFL, that sort of thing. And we have to have all the routing out to the pins and things too. So like it really is going to start to add up. It'll be simple routing generally, but just things we need to think about. And we're at an hour already. Isn't that fun? All right, let's see if we can fit enough pins in now. So we're going to go here. So now we have to take 1 off. So if we divide by 2, minus 1, so that's 26. Divided by 2 is 13. So we could fit 12 on this side. We could fit 12 on this side. And then we can fit 16 divided by 2 is 8, minus 1 is 7 on this side. So that would be 33. And I think maybe then all the optional pins we'll put up here, even though that would be like a long run for some of the ones that I talked about, like a DAC or a NFC or whatever. Mm-hmm. I just don't think we should use the real estate over here for that sort of thing. All right, so I'm going to go change how I do some of this stuff. I am going to get rid of the numbers on here. Can I do that? I think I could do that. So let's go back to the symbol. KiCad symbol editor. This is the footprint editor. Symbol editor. There we go. And I wonder, let's try this. Let's call it ground there. Oops, shoot, cancel. Let's get rid of these. Let's just call it G. Because you can have like a single connection here, and then you could have the pin, have multiple pins that just have the same net name, right? Mm-hmm. So let's try that. I think this will work. It's been a while since I made a module. Also, pad numbers are arbitrary. You can kind of call them whatever you want. Usually they're numbers, but I don't think they have to be. All right, let's save this, And ultimately, we need to go test it as well. Get rid of this. We need to go test this as well. So I'm going to update this symbol. Where's it? Edit, update symbol from library. This is the same thing I was doing on the footprint side. So now we see there's a single ground. And then I think if I connect this here, you should see a net connection hook up to this as well. That's what I really want to get. I need to go close my door real quick. All right, so we're going back to the layout. I'm going to say, so now these have not been updated. I can tell from the pins here. E, update from library, hit update. Now those all say G. And then what I expect is if I hit F8 now, because now the symbol has been updated and it's been hooked up to ground, and because the layout is now hooked up, I expect all of these G's to be routable to the ground right next to it. In fact, I think the name might even change. Let's see. Yep, there it did. So now all the G's, pin G, pin name G, has been assigned to the net ground. And I should be able to just go, well, I can't actually route that there. I can route it like this. It violates DRC because of the edge cuts, I think. So we need to probably play around with that. But that actually, I think there's a way we'll be able to, we'll be able to do that with ground pour. But I'll need to figure that out for other stuff with castellation. So that's a future to do there. Okay, so that G pin definitely worked. And so then I need to go change the rest of these. I'm going to change these to G. One second here. And Dan didn't even notice I wasn't talking. I was talking, but I was on mute. Sorry about that.
Yeah.
It's okay. Dan is hard at work coding new versions of pipelines, which you can see on our blog. All right. Last couple things here, hopefully. Okay, so now I'm going to go back into here, and now I'm going to go just assign generic numbers. So, and then we can kind of play with them later. So I'm going to change, you have to change the number here if you want it to actually increment, right? So now it's pin 1, 2, 3. Except I don't want to start there. I'd like to start over here, please. Let's start here. Start there. 2, This will give us a better feel for whether we have enough pins generally. Okay. Looks like we're going to make it. All right, so now we have these numbered pins on the card edge. And I don't think we're actually going to need all of them. In fact, we have 38. So let's see what we need here. So now I can go and assign, basically I can go in here and just say, oh, this one is pin. I think I can, unless it locks up on me. So if I did that, 35, I think it's going to go and assign that later. Update from library all the way around. That's what this is going to look like now. And now if I actually hooked up the schematic symbol on the actual, let's see, schematic editor here. So now if I said of this one's not updated either. Update. I should see a 35 here. So now 35 is SWDIO, which is not what I plan to do, but we could. And then I have to actually hook it up to something here. So let's do this, and then SWDIO. It's a lot of the same labeling everywhere, which is confusing, but and then I assign this to here. This one is not aligned, it looks like. Align items to grid. All right, and then I'll hit F8. That should actually go and assign that pin. Now we finally see pin 35 is, well, I can't route it because of something. I think the edge cut DRC, which I might have to disable. That then says that it wants to hook it up down to here, right? And that would be the same on all of these. Now that's the important thing to notice as well, is that Dram 2 and Dram 3 and Dram 4, they would all have SWDIO in the same location. So it's important to like know that and like be okay with that, right? Having it underneath the module, having to route to this pin field might be problematic, might be okay. That actually might be a good placement for these things like programming headers, right? Which are going to go either to, in this case, it's going to the 9151. It's going to go right here. But on Dram 2, it's actually going down to whatever the 52840's programming pin is. So it's just important to know kind of where all that stuff lives. All right, so we've got that. So okay, so now it's a matter of assigning the rest of these. Another important thing to think about probably is something like the, if we have an expander on the board, so on Dram 3, this has the ESP32C3, we'd probably also want to have the expander kind of in one corner. So we want to put all the S pins, say, in the lower right corner. Or maybe in the lower left corner near the 2.4 gigahertz radio, because it doesn't matter if that's got interference type stuff, because low and slow GPIOs are fine. So maybe we do that. So if we go here, so let's say pins, so we're gonna do 12. How many pins are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so there's 12 pins. So it'd say 6 pins on either side of this connector should be low and slow. So let's do that. So we'll say 14 through 19, 20 through 25. And then it comes down to just, this is now just completely arbitrary. Edit. Actually, we can do this in the, this is schematic editor. We want to go to the symbol editor, go to the pin table, sort by name. So this is 14, 15, 16, 16, 17, 18, 19. Let's do, we missed one. Oh yeah, some of these are not going to be in order here. That's fine. We're going to do oh, that's interesting. This is so again, this is another error on the an error. This is a spreadsheet kind of idiosyncrasy where I had been labeling these 0, 1, 2, 3, 4, and then 5 and 6. I decided to name them more specifically to the RX and TX because I want those to be kind of called out and blocked out from being used otherwise. So I guess we'll keep that numbering scheme. 20, 21, 22, 23, 25. Nope. Missed 2. So this is wrong. So this is 23. 4, no, 24, 25. 23S is assigned to pin 24, of course. Pin 24S is assigned to pin 25, of course. All right, so that's been updated there. This should be, let's update here. So let's update the symbol from the library. Should see the pin numbers now. If we go to the layout, we should see the pin name assigned, I think, because it's not going to be hooked up to anything yet. Might need to actually hook them up to something. Let's see the spreadsheet, 16S. It's a bad example. Let's do click CS1, DG24S, P03 on Dram 1. Okay. Let's label that click CS1. No, that's not a good name. Actually, let's name this DGS1, DG24S. This gets hooked up to P030. I expect this to now F8. Oh, that was the missing piece. All right, so now if we zoom way in here, we can see it says unconnected and all the different numbers here. So U25, DG09S. And that's because U25 is the number that is the pin that, or sorry, the part that got assigned to the footprint here. But this one should be hooked up. 24. So this one is actually Dram1 / DG24S1, 24S. And now it's not going to let me do that because of the board edge, but it's trying to hook that all the way up over here. Right. So this is trying to get all the way to here. Not a good layout technique there. Okay. The reason these are over here is we would have on the Dram 2, we'd have a pin expander. We do not have that on there currently. Probably should put some kind of placeholder in there at some point in the future, because especially we want to make sure that we could fit all this stuff in there. So the pin expander would kind of go over here. All right. Dan, what am I missing here? Dan and
yes, I'm
Jeweler.
here. I'm here.
Jeweler.
Well, we're missing lots of things, but
we are missing a lot of things. Yes.
So
the things that I need to do next, I guess that's probably the best way to think about this. Things that I need to do next is I need to go assign. I realize I'm not doing a ton on stream because honestly, this is the boring part of layout, but some people want to see it, I guess. I need to make sure all these pinouts work for the size. Looks like we have enough pins, which is good. Looks like we have, the ability to add another UFL in the bottom corner. That's kind of like a reserved area there. I need to make sure that we can make this work. I need to also make then a footprint for you guys that matches. Maybe we could talk about that real quick, what that looks like. So if I was going to make a similar footprint, sorry, let me turn the screen back on here. Okay. So we can go and make let's see. So if we go to the layout, the schematic, I'm going to go and copy this guy into the Dram on the Goliath area. I'm going to go and change the footprint though. So it's not going to be the Dram edge. It's going to be, what should we call the Dram landing, I guess.
Sounds good.
I need to go make that. Let's do that here. Okay. Oh, you know what? I should just copy it from here. Duplicate. Rename. Landing. And I think default pred properties. Let's try and do that. SMD. Make them rectangular. Want them to be, that's the right width. Let's make them taller though. Not sure if I could reassign these. Let's see. Computers slowing down for some reason. Paste default. There we go. Look at that. Magic.
Nice.
Yeah. Actually, let's just select all of them. Oh, yeah. Okay, that's the wrong direction though. So now I gotta go rotate all these. I'm not sure there's enough clearance there. We might want to make those a little small. Oops. So that's another thing where you like, oh, well, that's okay if those are touching, but that needs to be fixed. But like, do we have enough clearance to allow, to route through the pins as well? That's another thing to think about. And that ultimately ripple back through to like the size of the through hole that we're using for the castellated edge. Okay, so now we're in the Dram on the Goliath. We change this footprint to be the landing. Let's go update the layout. And this is not going to fit because the widths are wrong. So you see how I sized it for the board edge?
Right.
It needs to be sized for the edge of these pads. So it looks something like this. And then, yeah, obviously that needs to be resized. But then this extents of the pads then as well would determine basically the smallest board. So say we wanted to make the micro Dram, have the smallest footprint possible. It's actually going to be a little bit bigger than the actual module itself, because you need to be able to solder it down as well, right?
Right.
But can we route any wires through here? I am not so sure. Yeah, I don't think so. So I think we might want to reconsider on that side of things. Let's see.
As in they're too close together. Yeah.
Yeah. So like we could shrink down this is just at the width size of the trace itself.
Mm-hmm.
But ultimately, it's good they're not interfering, but we need to make sure that we can. I'm not actually sure what the width would have to be in order to do that, but probably want to you really want to size it so that like the smallest or like the cheapest, just using my past experience, the cheapest JLC process would probably be the best one. So I think that's like a 5 mil trace. Let's try that. So if we add a 5 mil trace here, let's switch to mils. Add a trace that's 5 mils. I think the spacing also might matter, but I think the default is set to the spacing or the clearance is still set higher. So I think really we'd want to make it so that these are a little bit smaller. So let's try and go into the footprint again. Let's edit the default properties. Yeah, that's the real problem here, is that the diameter of the actual castellated edge one is bigger. So we want to take this down to like 1.25 on the castellated edge, and then we could probably fit more stuff. So then if we did, that's weird that it changed back. I thought I changed that. So if we did this, right click, copy pad properties to default. Good. There we go. Actually, we probably do want to make it a little bit. So we probably need some margin on either side as well, right? So we probably want to make this like 1.3. And then select all these. Paste defaults. Oh boy. Got to keep doing that every time. Let's see if I can. Nope. Ugh. Definitely think this will fit through here though. And then we update this layout. That's saved. The landing's saved. Update this from the library. Yeah, that'll definitely fit through there now. Yeah, great. Okay, so something around that size as well. So that means we need to change the castellated edge to have a smaller through hole as well, so that these have a little more space. So that's set at 1.3. These are going to be, change these, default pad, 1.2. Let's knock this down to 0.6. Shrink all these down. Update this from the library. All right. And I know this is going to look silly, but so it looks like that width would work. Looks like we can also offset the inside pad as well, so those aren't interfering anymore. And that'll give us a little bit more real estate, I think, as well.
Okay.
So let's do that. Update library footprint. All right, so now we can do, let's go down to 2. Yeah. All right, last time. If anyone in this stream is watching and saying, there's a faster way to update these rotations, that'd be great to know. I'm guessing it's because the default rotation is as shown. It resets it each time I go back here. Paste the properties. Okay, so the landing should be good now. I'm going to update this footprint from the library. So it looks like we can get a default 5 mil trace through here. These are no longer touching in the corners here, so we should be able to get them. Can we get them through this corner? All right, I should probably change that one as well so we can get it through this corner. Maybe even just changing these two specifically so they're not default. .8. Copy. It's not this one. This one. Oops. All right, now that gets through too. All right, great. Well, this has been a bit of a wild ride. Wild, not like exciting, but like
Good
lack
progress,
of confidence.
the most
What do you think,
progress
Dan?
we've made on a stream, or you've made on a stream. I'm just sitting here. Well, I actually made a lot of progress too, but it was unrelated to this.
Yeah, I think so. We had to do items over here. Let's take a look at those. Okay, so to do items that are still on the figure out external memory, we have that on there. Secure elements on there. eSIMs on there. UFLs are on there. Determine the minimum feature set for castellated edges. I think that's done. Yes?
I think so.
Let's do. I don't think we can do strike through on here, but that's fine.
I always use
Determine
KiCad
whether we
for
want
my
to
note
chip
taking.
down. Sorry, what's that?
I said I always use KiCad for my note taking. It's my
Yeah.
preferred app for it.
It's really the most efficient way of doing things.
Exactly.
I think we've done all of these things, honestly. I think the new set of to-do items is test routing to each Dram module control chip. Mock layout to RF elements to make sure you have room. Sufficient room for controlled impedance. Still need to assign the pins. Create micro Dram board as test of smallest module user. And so I guess just to go back to the beginning of the stream, this is the size of the module. Looks like one of those remember those like
Listerine things. Yeah.
Yeah. What was it called? Listerine strips?
Yeah.
Those really
like
are those around still?
I don't know. I haven't seen those. I feel like when I was growing up, they were like, I feel like people use them like candy though.
Yeah. Yeah. And they always left like that super metallic taste. And
yeah, those.
And I always started seeing things like pink elephants and rainbows. Was I taking the right type of strips?
That was a different thing.
different thing. Yeah. Anyways, this is the relative size of the module itself. But then remember the size of the landing board would need to be a little bit bigger. So I think that's probably an important thing too, is to have the micro Dram right there. Dram module, 2 projects being shown. I need to update that as well. And that's really just to kind of like test a lot of our assumptions here, right? So like, what does it look like if you have a micro Dram just has microbus headers, one set of microbus headers, USB to serial, probably regulation off the 5 volts on the USB. That's about it. I mean, I don't think there's much else going on there. And unfortunately, it's on the back side. It's not on the front side. That's something to note there too. Need to widen the Goliath Dram on the Goliath. Extents of Dram landing footprint. Anything else, Dan? What else am I missing? Start layout, right?
Right. We could, I mean, maybe on the Friday stream, we could start thinking about what the landing board looks like for Sloshy McWashy.
Yeah. I think some of that's a good one too, because that's like, that plays a lot of the mechanical elements. Like that's one of the key features there. But like even just doing some paper prototyping where it's like, all right, how big, so we talked about like the Thingy 91 there, but like how big does this need to be, right? Like this almost certainly is the proper size for what we're talking about. Like this will fit a lot of form factors, which is kind of we're talking about the minimum feature set, minimum sizes that we're playing with here. But then does it work in that context? And like, what is the mechanical constraints that are going to drive a lot of that stuff? Like the small size of this is way overkill for a lot of the things we've been doing. Like even just thinking about like that, of course, I ever had any props ready to go. Do not. Looking for an elixir port, just so that's not clear.
I've got one here.
Yeah, but you don't have a Dram size thing. So like this is the relative size of the Thingy 91. Oh wait, I know where it is. There we go. All right, this is the relative size of the Dram. All right, so we basically could replace a lot of that stuff. This is overkill, right? We have so much space on the elixir board. Like this is super overkill, and yet it's still an interesting thing because then when you take this off, the idea being that if you start with something like the elixir, using this for prototyping, what you'd probably be doing is you'd be using clickboards to start with, talking to the Dram module through the USB to serial here. And then when you're ready to take this to something closer to production, you take whatever sensors are on the clipboard, put those onto like say we're just making sloshy McWashy, and this has an accelerometer on it. Did we talk about microphone at one point? I think we did say a microphone. Did we talk about microphone? I don't remember, Dan.
I don't think so.
No? Okay. Oh, maybe a tilt sensor? I thought there was some other kind of sensor, though. Doesn't matter.
Yeah.
Whatever the other sensor might be, if there was other sensors, you take those, you put those onto an actual board, and then you take the Dram module and put that board on there, to put that on the board as well. So that's kind of that's the vision we're working towards, but not necessarily what we have to do. Oh, wow. Looking at this like really up close, the bounding box that I put around the original, it's almost fits perfectly. So that's pretty cool. Nice little validation of what we're doing here. It's just coincidence, but it'll just fit in that same area. Okay. I know this is another unsatisfying. We still don't have a module or really any traces. But you note that I did not list layout in this promotional thing here. So
this is true.
Yeah. Okay. I guess, oh wait, one other thing I should update here. So these are proposed versions. 9150 with ESP32. That's with the BG77, C3, 77. Yep. And now there's a fourth one. These don't need to be the only versions, of course, but again, we're just trying to create a smaller feature set so that we have coverage. What this is ultimately going to be doing, I think one thing to think about here as well is that once this form factor is set, whatever it ends up looking like for the module edge, that's it. So like you want to move outside of that, you want to use a cell module that doesn't fit on that board, it's no longer a Dram, right? That's really the key thing to think about there. Just because of the form factor and what you can do there, say you need some other kind of crazy capability that's not currently covered on the card edge, on the castellated edge, then there's nothing you can do. So, okay. I'll probably be doing a little bit more work off stream. I know that Sloshy McWashy has a very stringent on stream requirement. I don't limit myself as well, but I will do some more off stream stuff there. And then hopefully when I actually route some wires the next time when that finally happens, you'll see that on stream. And boy, are you going to be underwhelmed when you see just how boring layout can be. Thanks everybody for showing up or watching after the fact. You can always find us over at the Goliath forum, forum.goliath.io. You can find Dan and myself and others from the Goliath team on Fridays. We have a Friday live stream as well, where we're working on Sloshy McWashy and other IoT type projects, talking about our pipelines. So thanks for coming, Dan.
Thanks for having me.
See you soon.
See y'all.